Okay, we're getting ready to start Limits 8, which is complex fractions. We're going to have to remove the complex fractions by playing What's Missing. Of course, you will need to show the unit multipliers to make your professors and me happy. You will see that a pattern is going to develop that I will teach as I go. The first term in the numerator will have the numerator times the second term's denominator. The second term in its numerator will have its numerator times the first term's denominator. The original denominator will keep its denominator times the denominator of the two terms in the numerators. Then, of course, you will simplify, reduce, and evaluate. Now, this worksheet has these 6 problems, 1 through 3, 4, 7, and 8, that match what you typically see in a calculus book. When I go ahead and try to plug in 0, 1/5 minus 1/5 is 0, and that's over 0. So I have this indeterminate form, 0 over 0. So I'm going to have to do more algebra as always. And in this case, I'm going to multiply by the common denominator of the denominators, because what I always have people do first is put brackets around the numerator and, of course, put your over 1 in your denominators so you can see that the common denominator is just made up by the common denominator of the numerators. Please always insert those square brackets, because if you don't, you're going to get caught with your pants down at some point. So you're going to multiply by the unit multiplier. You will show this work. So I'm going to indicate just one time a bunch of extra work. And so when we play What's Missing, you can see the second denominator is 5, the first denominator is x plus 5, and I'm putting them both in the denominator so you get the feel for what's going on. Notice we still have the brackets. Here I didn't do an extra step because everything is positive. So 5 minus 5 just disappears, and all you're left with is negative x when you simplify. So feel free to just do this. You have no issue with that. And now we can simplify. We'll be able to cancel this x and that x. And you are left with negative 1 over 5 times x plus 5. So when I insert my 0, I get negative 1 over 5 times 5, which is negative 1 over 25. And yeah, this is going to be the pattern. The parenthesis will always turn into the constant multiplier. Right there is your constant that's in front of what you're multiplying. I mean the constant factor. And when I have a 5 here, I'm going to end up, when I do my plug chug, with a 5. So let's look at a second example. So here's the second example. It's similar. Do you see how I inserted the square brackets? If I insert 0, 1/2 minus 1/2 is 0 over 0. It's an indeterminate, so I have to do more algebra. Yes, what is my common denominator? Now that I look at all of them, it's 2 times 2 minus x. And I'm going to show multiply by the unit multiplier of the LCD. But I'm going to play What's Missing, but we're only going to see that in step 2. So I come over here, so this step is all for show. So I have everything set up, and by the way, you can do that right up here to the very original problem. You can put in the square brackets over 1. You can put in this. So this can all be done straight to the very first step. And now I'm going to play What's Missing. What is this term missing? It's missing the 2, and 2 times 1 is 2. And what is this term missing? It needs 2 minus x. And what is 1 times 2 minus x? It's 2 minus x. And the denominator gets the whole kit and caboodle. Now in this case, because there's a minus sign and I see a negative, it would behoove you to show the next step where you're going to go ahead and multiply, because you turkeys gobble all the time and in your head say, ooh, it's a negative x, when we see negative times negative as a positive. I'm now simplified, so I'm just an x. And now I can reduce, and the x's cancel, and I'm 1 over, and you got it. You see the 2. This is going to turn into a 2 because the original problem was 0 over 0. And so I end up with positive 1/4. Now, there are 4 problems on the sheet that got on here, in a sense, by mistake. We try to do something out of that crazy CUDA math, and this is always what happens. Is 4, 6, 9 are going to have an over 0 somewhere in it, and so it's going to cause you issues, and you're not going to be able to just plug chug. But number 10, you can just plug and chug if you feel comfortable with fractions. Go right ahead and do it. You don't have to do any of this extra work because it's legal. But in this one, when I plug in the 5, do you see it's 1 over 0? I can't do 1 over 0. Don't know how to divide by 0. So I'm going to do this one, at least simplify it, so I can get rid of that 1 over 0. And so my common denominator is this. So just pretend like this is the original problem. And so I have my square brackets in. I'm ready to go. This now doesn't have the brackets, so it just gets everything. And this one had the brackets, and 5 times 1 is 5. And 1 times x minus 5 is x minus 5. And so I'm done. And at this point, you don't have to cancel. You could go ahead and plug chug. I mean, you're going to get an okay answer because you just needed to get rid of that term. But why plug in there? Why not just go ahead and cancel? Because it's a lot easier on you, and I get 5 times negative 5, which is negative 25. Now remember, it's just 4, 6, 9, and 10 don't fit the pattern of being an indeterminate of 0 over 0. Notice 4, 6, and 9, you must do like this example. 10, if you feel comfortable with fractions, feel free to go ahead and just plug chug because it's just an arithmetic problem.